I'm happy to be here to participate in this symposium honoring Nick Dunning's many accomplishments and to thank him for the many accomplishments that he's guided me to. The many things have prompted this presentation, and there only a bit of them are reviewed here. But most immediately, a study by Claire Ebert and company has suggested that if you look for a transpeninsular trend anywhere in the downfall of large interior cities in the Yucatan Peninsula, it's either not there or hard to spot, and they seem to be collapsing in rather random fashion. I would have thought that it would have started from the northwest to the southeast, following the trend of the ecotone between the northern scrublands and the southern forests. But if anything, it goes the opposite way, and it's, as you can see, pretty difficult to identify immediately some kind of a trend. This reminds me of something I've seen before, which is an article that Willie Folin and I published in 2000 on the effect of global average temperatures on discharge from rivers, and they, like the clusters of cities, are idiosyncratic. The Champatón River, for instance, is highly dependent on local anthropogenic effects such as deforestation and floods because of those. But you go to the next river to the south, the Candelaria Caribe, and it's much more dependent on solar emissions. And then the Usumacinta drainage, a much more highly diverse terrain, is chalks in on global warming at the global scale. And so this, of course, calls to mind the use of multiple regression, which we did, and this is how we determined that these various discharge zones were the product of one global change variable or another. Here's your solar activity. This is a measure of volcanic activity. That is El Nino activity, and these are two ways of looking at human impacts on the atmosphere. And here's a large beta on local activities in the Champatón, Candelaria, highly influenced by the changes in solar energy output, and the Usumacinta, which is influenced by global warming trends. So another motivation for this talk was that Nick and I had a little chat a few years ago, or I would say at least 20, about what the impact of the subsurface geology was on. He told me, well, I should be studying substructural geology, which I have no acquaintance with in particular, other than reading about continental drift and the like. But as it turns out, there's quite a bit of interest in the subsurface, the geology, and particularly in the immediate subsurface in the middle Yucatan Peninsula, which peninsula was originally a a platform under a shallow sea, which formed these great bedded limestone gypsum beds. But then there was the great Chicxulub event, burning, no surprise there, and then piles of rubble. Those piles of rubble particularly felt at the impactor hit up here by Merida. But if you look at where the most mining is going on, it's on Highway 186 between Escarcega and Chetumal. And the previous photograph was taken in this little square here. But these are other excavations to mine those deposits, and they are north of Calakmul and the El Laberinto Bajo. So I'm thinking, and have been for a long time, that the El Laberinto forms a boundary between these more easily conquered terrains to the south and the much more difficult and much more gypsumized terrains to the north. And it required tons and tons of engineering capability to get into these northern areas. And fortunately, not only do we have subsurface geology, but we also have new surface collections of ceramics from places like Chuktoon by Jan Spatzik, and we have new climate data by Nuria Tarascano, and she has studied the geochemical characteristics of lakes underneath the lower edge of the Petén syncline, and she compares it with the other lakes that have already been studied, Chichen Kanab and Tenisa. And if you look at the evolution of cities, they start very early on the Sumacita, and then they spread north into the Lake District, Knock Bay, and ultimately to El Mirador, each with a more complex way of collecting and storing water and making use of it. And then at the El Laberinto boundary, it stops for 1,000 years and then moves on north from there. This is the Chuktoon surface collection over the periods of Maya civilization. As you can see, there isn't very much going on in terms of ceramic collections until the late Classic, and then there's a tenfold increase and then a drop back to the old very sparse conditions previous to the late Classic. And I want to suggest that maybe developing all that fancy engineering, putting it on tops of not so great soil substrate for soils and the like, creates a kind of an abbreviated span of time for hyperurbanism, which am thinking of in terms of urbanism that exceeds the sustainability of its surroundings. And I'd like to put a couple of more things in this in a mix of 5 different variables. First is the hyperurbanism and the clustered collapses that were identified by Claire, and those are quantified and I think pretty reliably sustainable, and so I'm giving them 80% probability of contributing to a post-classic collapse reorganization, and whether that reorganization would turn out to be unsustainable or whether it would prove to be chaotic or some kind of a normal organization. Then there's a couple of other things, a new climate thing that I've been working on, which is changes in prevailing winds with global average temperatures. And another idea that I'm interested in, Simon Martin's idea that there was some kind of an institutional decision around 810 that made it to abandon the interior cities project, and probably the elites of those interior cities moved to the coast where the economics were moving anyway, because by then the Maya had been working on coastal networks and another kind of engineering, how to make commerce work at sea. Those are ideas that are still kind of anecdotal and a little bit intuitive. And then something else that just occurred to me while I was working on this, that there might have been an abbreviated military reach in the late Classic because of all of the fragmentation. And so dropping back to, once again, multiple regression, you can see here the combined contribution, the probabilities that I assigned to them, 80, 80, 70, 70, 60, and how those contribute to some kind of an economic reorganization, a transition to a new reorganization. And my intuitions are that bring it to a probably 96% probability that there's going to be an orderly transition, and sorting that out into three different categories. Would they succeed at making a continued use of the total terrain of the Yucatan Peninsula to continue with large cities, or would it fail? And at 11% probability, that seems pretty unlikely that such a stable attempt would be possible. A fragmented order is somewhat more likely, and I take that to be the terminal classic, the period of encapsulation of cities, but the maritime reorganization grabs a 68% chance of such a thing going on. So that's our first look at this. Actually, it's a second look. I've tried some other earlier things and decided they wouldn't work, and came up with this 80, 80, 70, 70, 60 combination of things. But anybody gets a shot at defining these variable probabilities and other variables or fewer variables or whatever. You just plug them in and run the equation, which will appear in the appendix of this paper. So thank you for your attention.